the 45th episode of PEEPanEIP, an educational series where we learn about Ethereum improvement proposal, upcoming feature, and important concepts. Basically, every key term you want to learn about Ethereum blockchain. I'm your host, Pooja Ranjan, and with me are William Schwab and Brent Alsop from Ethereum Cat Herders team. In this episode, we will be talking about EIP-1271, Standard Signature Validation Method for Contracts. This proposes a standard way for any contracts to verify whether a signature on behalf of a given contract is valid. It is a standard track EIP under ERC category, created in July 18. The current status is last call. Well, technically, it is eligible for moving to the final status as the last call review period has already passed. We'll discuss about it and more. To talk about the proposal, we are joined by one of the co-authors, Philippe Castonguay. Thank you for accepting our invite and joining us on the show. This is the first time we have you. Maybe we can start with your brief introduction and a bit about how you got involved with blockchain and Ethereum community. Then we'll get into the proposal. Welcome, Philippe.
Thank you. Sounds great. Happy to be here. So I've been in the Ethereum space since late 2016, full-time mid 2017, and I've worked on various projects and contributed to a couple of ERC standards, such as 1155 and 1271 are the main ones. And I've been working for the last 2 years at a company called Horizon Games, and we are building a few products, one of which is called Skyweaver, which is a TCG based on blockchain technology. We are on Polygon and Ethereum, and we also have another product that we have launched, but is still in testing phase, called Sequence, which we might see in one of these slides when we talk about smart contract wallets. Yeah, so this is me, and I can jump in the 1271 if you want.
Yeah, thank you so much for the introduction. So without further ado, let's peep in.
Okay, so this is 1271, and as Pooja said, this was introduced in July 2018, a bit earlier. It was actually an inspiration from a piece of a snippet of code that the Xerox protocol implemented way back in 2017, but it hasn't been really adopted elsewhere. So we took that snippet of code, tried to formalize it better so that other projects can use it. And yeah, so I'll go a bit in what that proposal and the standard looks like. But before, I just want to briefly do an overview of why it matters and why do we care about contracts doing signature validation. So there are a few places that we need signatures in Ethereum, but why specifically contracts would need to sign, right? And one of the main one is for authentication. So this was the Ethereum Foundation with ENS made this request for proposal around kind of a project of signing with Ethereum, try to standardize and have a flow. And it's not yet finalized. I believe there's a few applications still that are being processed. But the idea is to have a button, a bit like sign in with Facebook, sign in with Google, and now we would have sign in with Ethereum. And this, so signature, and this is usually using signatures. Most of these proposals request a signature from a wallet, and then the application will authenticate that signature as a mean to authenticate the user to prove that you are in control of a wallet. This is an example of ETH-auth, which is the example that they use in the proposal and the RFP as what they're expecting for submissions. And you can see that there's basically here two paths. Log in with an Ethereum wallet. This is for regular Ethereum wallets such as MetaMask and Wallet Connect or derivatives. And these use a simple private key. Whereas login with contract wallet is a path where if you use a smart contract wallet, such as, for example, or multi-signature wallet, you can sign with the contract wallet. And this proposal uses 1271 as a mean for contracts to validate the signature. So authentication is a big one. There's a lot of applications such as OpenSea and such that request users to sign in order to prove that they control a wallet. So if users have a smart wallet, a smart contract-based wallet, then it's important that they're able to sign as well. And why contracts now need to sign. So another example is for order books, such as, for example, OpenSea and Matcha. These requests, if you want to place a bid or if you want to create a limit order, this is usually done off-chain, so off-chain order books. In order to do that, you have to sign a message with the payload of your bid or your limit order. And of course, if your funds are in a smart contract wallet, in order to sign for the contract, for these contracts, Matcha, 0x, and OpenSea, for these contracts to recognize the signature from a contract wallet, they need to be able to validate the signature, which is where 1271 comes into play. So how do we support ERC 721? So I'm briefly going to go over the standard. It's a very, very simple standard. There's very little to implement, so it's very easy to adapt. But this is really the core of it, and that's pretty much all there is. So a contract that wants to basically sign or validate signatures needs to implement this function called isValidSignature, which only takes two arguments: the hash that is signed, which is the payload that is signed, and the signature. And then if the contract determines that that signature is valid, it needs to return that magic value, which is specified at the top here, the 1626 BA7E. The reason for that I can explain if you're interested, but instead of just returning a true or false, which sometimes can be a bit misleading if it was an error or something else, this very specific value makes it easy for the contract that calls it to know that this is indeed a valid signature. And it's really up to the contract to implement the logic of what determines a valid signature. If it's a multi-sig, then the signature may be very long, a concatenation of multiple signature from users, but there could also be timestamp related issues where if part of the signature, a signature is only valid for a couple of hours, maybe a contract within the isValid signature could decide that there's a time limit for that signature to be valid. So it's really up to the contract to determine what defines a valid signature, but the interface is the same for all of them. There's a hash, there's a signature, and if you want to check that this contract authorizes a signature or that a signature is valid for that contract, you just pass these two arguments. So for example, let's go now with a signer contract example, just as an example implementation, that this one checks that the signer is the owner of the signing contract. So that contract could be, again, like Argent or smart contract wallet or multi-signature. And it just check if the you recover the signer that signed the hash, and if that's the owner, you return true. If the signer is the owner, then it returns a magic value. Otherwise, it returns another value. That way, people could validate that the signer is indeed the owner of that contract. So that's a very simple. That was an example of a signer contract. Now, what about contracts that want to validate signatures for using 1271? So you could have a method called ERC-1271 isValidSignature that takes an address, a hash, and a signature, and then you just call on that address that method isValidSignature, pass the hash, pass the signature. If the result is the expected one, then everything is fine. So you require that the result is equal to that magic value. And if it is, then you know that this is a valid signature for that contract. Okay, so that was really the core of it. And again, maybe just to reiterate, this is really important because a contract needs to be able to signal what it defines a valid signature. And the contract itself should be the only entity that knows this is a valid signature, this is not a valid signature. And the limits there are really like endless. You can have very abstract signature validation per contract if desired, using different types of cryptography curve. Okay, so now as example of ERC-1271 support. So this is actually a standard that has been around for almost 3 years, more than 3 years now. So a lot of projects have already adopted it, even though it was not finalized. The main adoption comes from all the smart contract wallet. Pretty much every single smart contract wallet that exists out there supports 1271. Here are the example I could think of top of my head: Dharma, Argent, Sequence, Agnosis. If all of these have this method implemented. So if dApps want to validate, if a user comes with Argent, for example, and goes to a website, that website application can validate signatures from Argent by using 1271. Now there's a few also dApps that support it. Matcha, which is the aggregator from Xerox. You can sign limit order using 1271. So that means you can sign limit orders with your smart contract wallet or multi-signature wallet. Aragon as well uses it for governance votes. Rarible uses it, the NFT marketplace. They use it for if you want to place bid on NFTs, you can use your smart contract wallet by signing messages via 1271 as well. And these are just a few of one. I know there's others that they use, but that's the list I could think of. And yeah, that's actually pretty much all there is to that standard. The more people use it, the better it is. And yeah, if I know there's a few questions, maybe we could jump to that and have a more open discussion.
Well, thank you so very much for this presentation. Yeah, yes, we do have got some questions. So yeah, I'd like to open the floor for other participants of the con to go ahead with the questions first.
That magic value, where did that come from? The 1626, is that a random number or
it's a good question. So the magic value comes from actually this little line right above. It's something that other standard have been using because it's fairly easy to remember. You just take the first 4 byte of the hash of the basically function signature that this standard is referring to. So if you just take the hash of the valid signature function by 32 bytes, and you take the first 4 byte, it's going to give you this.
You talked about a lot of use cases in terms of basically cases where we'd want a contract to be able to act like a normal user. So you've got Argent, or for like, you know, a wallet being able to do wallet-like things, or OpenSea for being able to sign on the order book, Aragon for voting. What other apps or what other applications, probably even more than apps, do you think will get built on top of 1271? I mean, 1271 purposely keeps itself simple, like you've said. And I've also noticed in the official comments on the issue and GitHub and whatnot, ideas of ways to extend it, maybe even give it more functionality. So where do you see 1271 going from here?
So to answer the first question, yeah, like definitely everything order book related or a signature intent for specific actions there's a lot of applications there. The main one today and since the last few years have been signing orders for trading. It could be like on DYDX, Xerox, whatever marketplace that uses limit orders or order book. This is probably the main use case, but you can also have things like you could implement it such that E2 validators could use multi-signatures or a wallet contract as a mean to sign. Currently, the Ethereum 2.0 only supports EOAs for validators to sign, but you could add 1271 support for smart contract wallet. So that would be another application that is a bit out of different than the order book. I'm sure there are others. Can't really think of top of my head, but in terms also of where I see the future of this standard, there's a lot of discussion, which I think is one of the reasons why it took a while for us to finalize about how expressive we wanted 1271 to be, and we went with the current design specifically because it's very simple, and it's, you know, if we want to add additional functionality, the consensus with all the people that participated in the design of that EIP was that other standards should be proposed. And examples of that would be, well, instead of having a hash, what if we pass a data? That data could be decoded and interpreted by the signing contract, such that you could have a slightly more flexible and creative signature validation, such as you could pass a timestamp in the bytes, or you could use EIP-1271, which is a sign type structure data that the signing contract could decode and look at the data that is signed, not just a blank signature. Because you could have a smart contract wallets that care about not only if that signature is valid, but what it's signing, such that you could say, well, okay, yes, that signer, I want that signer. This is a valid signer. You could imagine like a DAO or something that has hundreds of people that can sign, but the signature does not have the same abilities, or different signatures cannot perform the same action. So you could say, okay, well, if you pass more data into this is valid signature instead of just a hash, you could say, okay, well, that signer is trying to purchase, $100 worth or 1,000 ETH, right? But 1,000 ETH is beyond its capacity to purchase, therefore rejects the signature as being invalid. So that's not really possible with the current 1271 implementation, but there's not a lot of people that had like concrete examples of using extra data, passing a data array, a byte array instead of a hash. So that kind of like was left on the side for future EIP because it's a lot more complex. How do you encode that data? That has to be standardized and things like that. So yeah, I think 1271 is probably going to stay as is for a very long time. It's self-sufficient. And yeah, if there's extensions that are proposed, then they would probably become new standards.
Right, I'm a big fan of building block EIPs. It happens to be to have like one standard and then have other standards that kind of build out and build on top of it. So, I definitely don't mean to suggest that 1271 needs to incorporate them or have like 1271.2 or anything like that. But it's interesting to see where things will go. I think the truth is, I think you've already partially answered this, but it was something that I wanted to ask. So maybe I'll just try and also put like a bit of an emphasis on it. In terms of ERC 165 or ERC 712, like you mentioned, I could have seen them having a place here, like, making sure that a contract is 1271 compliant or using signature style for 712. Why did you decide to make 1271 kind of independent of those?
Well, in the end, if the signer contract, so starting with the last one, which is why not care about 712, just only taking a hash and then signing it, I think makes it simpler for implementation. Now, it is true that contract may not be able to construct the hash and then send a request for signature validation because they may not know how to construct that hash in the first place. So it's expected that that hash would be passed from perhaps a client. So it does cause some limitations here, but in general, so long as you have, usually each application are going to have their own, signature, not signature, but data encoding and data hashing, and they're only going to care about that specific hash structure. So in general, I think just having a hash is sufficient. So 712 would lie more on the dApp side. So for example, 0x or OpenSea could require the data that is signed to be using 712 encoded and then hashed and then signed. But 1271 does not care about this. It just, so long as you send it a hash and a signature, it doesn't really care what the data is. So I think that's why it's sufficient on its own to just have the hash, not specify how the hash is created. And for your second question of ERC 165, this is something I saw the comment a week ago. I forgot about it, but this is actually a really interesting idea, and I think it's fairly standard now to incorporate ERC 165 in other standards. So I could definitely see adding it. The only reason why I could see people maybe being reluctant or feel like it's not necessary is the fact that there's no other standard for contract signatures. So if that call fails, if I detect that a user address is a smart contract, then ERC 1271 is pretty much the only option there is for signature validation at the moment that is standardized. And if you call is valid signature and it throws an error or returns a value that is unexpected, then it's very unlikely that signer contract supports any contract signature. So that's my argument as to why maybe ERC 165 is not needed, I'm super happy and open, of course, to include it because it's a small component, but I don't know if, because 1271 has been in the wild for a long time, which means a lot of people already incorporated it, and it's unclear to me if all of them already support ERC 165 already, and I wouldn't want to, put them as like not standard compliant for that reason. But yeah, happy to have opinion from other people as well on this.
Very interesting. That's it for me on the technical side, but you did start mentioning kind of the process of 1271, and there's already a lot of people who are incorporating it. And I know Pooja has some questions about kind of the process and the history of 1271 so far, and also the current ecosystem support. So I'm going to hand over to her.
Thank you, William. So yeah, before we jump into the process question, I think I may have a follow-up question on this 165 comment. There was this another comment, like, shouldn't this be an interface EIP that make use of ERC 165? What do you think in general?
So just to be sure I understand the question, so would be in addition to this interface here, it would be an interface for contract interacting with ERC 1271, such as like something like this, for example?
Yeah, right.
So this is not standardized. This is just an example of a contract that would call is valid signature. Did I understand the question correctly?
So the question here is, at present, that the proposal is in form of an ERC, not as an interface proposal. So it is on different types and categories of EIPs. So there are 3 different types of proposals, meta, standard, and informational. And in standard, we have different 4 categories. One is ERC, one is core, interface, and networking. So when we are talking about interface proposal, basically that is there for interaction of like contracts on different levels. And because this is actually helping validating the signature of non-EOA contracts. So the person, I believe, is trying to ask here, like, why not an interface proposal? Why you are going with ERC?
It's a really good question. Back in the days when we created 1271 3 years ago, most standard around contract interfaces, if you look at, for example, ERC 20, ERC 721, they're all interface standards, but they're all labeled as ERCs. Perhaps that interface standard was not something that was either very popular or maybe didn't even exist when we proposed this. But I would put it in the same category as ERC 20s and ERCs 721 because, yeah, they're all interfaces. So yeah, I mean, I don't see why it couldn't be an interface standard.
Right, yeah, interface category is really not so very popular. We have very few proposals which are in final status, and like now also there are some distinctions going on. We are removing some of the already standard, moving out of the interface category and having them like living somewhere else. It's at ETH1.o spec repository, but that's a part of process. Nevertheless, yeah, we are happy to see this proposal moving as a standard, even if it is going as a part of ERC, that completely on the author's side, like what they want to do with the proposal.
Right.
All right, moving to the next one. My next question is related to the status. I know that the proposal has passed the last call review period. So are you planning to move it to final soon? Do you think the proposal is ready, or you see some more work to be done into it?
I think I would like to have a brief discussion around 165 support for it. I didn't have a chance to see other people's opinion on it other than the last comment in the thread. It's a bit unfortunate because ERC 1271 has been, it took a very long time to come out of the draft stage, mainly because people use it already from the draft, and that's how everybody knows it. So I think people kind of assume that it's already final, and And so that's why there's very little discussion around it, and people just use it as it's defined. So yeah, I'd be happy to finalize it like this without ERC 165. But if there's various people that express desire to add 165 ERC 165 support, I could see that being added before making it final, just for making it very complete. But other than 165, I can't really think of anything else in that standard that would be changing.
Right. So just for your information, generally this is completely on the author whether they want to implement any suggestion provided by community or not. If they feel like that this is good proposal and they want to go ahead with that, that can be considered as a standard. Now that you are already into last call and you have received a few comments, and it's completely up to the author that they want to do it. If you decide to go ahead without integrating 165 into it, that's fine. And people who are planning to who are suggesting or planning to have something more added to it, they can always propose a new proposal with having this as like a required proposal. Like this would be the base proposal for them, and on top of that, whatever feature they want to add, they can go ahead and do that. And just one more comment I want to add here, because I know the new process is not very popular. A bit, it requires some kind of awareness. So just on that, I find that the discussion tool link is at the issue of the EIP's GitHub repository. There is another forum called Fellowship of Ethereum Magician, which we have found are very helpful for people to discuss. So I'm not very sure that this is the reason, but this can be one of the reasons of getting less comments. So there is this one more thing I wanted to bring it here about the EIP status. I am aware that there was an attempt to move the proposal to the last call, before we did it recently, but it was suggested to move into the review phase instead. And it was done, and now finally it is at the stage where it has already passed the last call. So that is something new that we have done recently. And I know that there are many more proposals which are still in draft. People are using it and they are not sure that it needs to be moved ahead. And they are waiting for getting more comments by editors or peers so that can be moved to different statuses. Just for EIP authors out there, it is important to move the proposal from draft to review in order to get attention of EIP editors to get your proposal formally reviewed. Once that is done, we would like to make sure that proposal goes into later statuses and become a standard by achieving the final status. We are actually putting a banner out there on the eips.ethereum.org that the proposal is not a standard until it reaches the final status. So please put some effort and reach to any of the cat herders. Will try to help you with the process and get it to the right status. My next question is related to the timeline. Like we discussed that this proposal is out over 3 years, and I'm very surprised to see that it has got over 100 comments, right? So I'll be a little curious. What do you think could be the reason of delay for moving towards standardization? I saw that comment started in 2018 till 2020 it was there, and then there was some gap and then coming back in 2021. So was it the readiness of proposal, you would say, or implementation going on in different projects, or was it the lack of responses received?
There's definitely a few things. I'll maybe shoot myself in the foot, but I think the number one was laziness, mainly on my part. Just didn't really. It was in draft. Everybody used it as if it was final, and then I think we tried once to put it in final call, and then it didn't work, and other things came along, forgot about it for a couple of months, and then shoot out to Pedro Gomez from Wallet Connect, ping me, put a message like, "Hey, why is this not final? It's been years." And then, at that point, which is a valid point, then we just tidied it up, submitted for review, and then last call. So I would say number one was laziness, but before that, there was a lot of projects that wanted to implement this. A lot of different smart contract wallet, a lot of applications, and some of them had slightly different needs. And there was a big debate around, should it be a byte 32 or a byte array. And that took, many months of back and forth. And it was never clear. It was almost always 50-50 what people preferred. And I think, letting the space mature a bit more, letting these applications in a while emerge. People were speculating that the byte array would be useful for some, but in practice, after a year or two, we didn't see any application that needed the byte array, and everybody was only using the hash. So I think at that point, the tide shifted to say, okay, we'll just use byte 32, pass a hash instead of a byte array, for simplicity, and in practice, it seems to be what's mostly used. So that also, I think, delayed. So that would be the second two. But yeah, for sure, number one is laziness on my part. So apologies for that.
Oh, no worries. I didn't mean that. I just wanted to understand. Like generally what happens after a year, it starts getting piled up and it goes like to the bottom of pull requests or issue section, and it does not get the attention that it needs to be.
Yep, that's very true.
So I think I am done with these questions on the process side. If you have anything that you would like to suggest us, the team, the process improvement team, like how we can be more helpful, because I see there are a couple of more proposals. The one on top of my head is 1155. So these proposals, I think they might need some attention and some talk. And if people are interested to move it to the final standard, we are willing to help it.
Oh, right. Is 1155 not final?
No.
Is this another one that we forgot to push forward? Okay. Yeah, I'll speak with the other co-authors. Yeah, again, it's because it doesn't change. Well, I think most people assume that it's final. So again, it's more laziness, I think, than anything that prevents them from being finalized.
Let me quickly check if it is final. Oh no, 1155 is final. I think, yeah. Sorry.
Okay.
That's my bad. But that is something that people are looking for, and we might want to have you or someone from the team to talk about 1155 maybe in the future. So yeah, that is another thing. Okay, on the part of pushing it towards the final, the simple process is you would want to create a pull request if you would want to push it to the final status. With that, I think I am done with all the questions. Does anyone on the call have any further question on this proposal today?
Yeah, so my question is kind of, what is the current way that this is done? Because if I'm understanding correctly, what 1271 really implements is the ability for contracts to sign their own messages. Is that what this is? And if it is, then how is that currently done, or is it just not?
That's exactly what it is, and how it's done is these contract, and just to give examples, like all these wallets are smart contract wallets, which means that the users, instead of the funds being in the address or the private key public key pair of a user, like in MetaMask, all the funds of users using these wallets are in a smart contract. Now that smart contract has its own ownership rules saying, okay, well, all of these addresses are able to transfer funds from the contract. So you can have multiple owner of a wallet, for example, or you can have a multi-signature. You need 2 out of 3 owners to sign before you can take out your funds from Argent, for example. Or Gnosis Safe. Gnosis Safe is mainly used for multi-signatures in many cases. This is where a signature is a bit convoluted, because imagine Gnosis Safe that is used sometimes by corporations with 7 signers. What is a valid signature for Gnosis Safe? Well, I mean, there's a lot of signers. We can't really. There's no way for us outside of that contract to know for that contract what is a valid signature. So Gnosis Safe would implement that function within its contract code, and you could call it passing a hash and a signature byte array, and then Gnosis Safe would say, yes, this is a valid signature according to my own definition of what a valid signature is. So that allows basically all these contracts to define their own rules of what defines a signature, a valid signature. And for example, as an example of like application that uses, I showed here, but like on OpenSea, whenever you place a bid to buy an NFT, you have to sign a message this is an example coming from MetaMask. But if it was, for example, you were trying to sign a message, and I don't think OpenSea supports 1271 yet, Rarible, and I think Super Rare does. But if you had a smart contract wallet such as a Gnosis Safe, for example, a multi-signature wallet, it would, instead of you would sign a message, but the OpenSea or the dApp would need to call that function here saying, is that a valid signature first, in order to make sure that this is a valid signature that is being signed for that wallet. Yeah, does that answer your question?
Yeah, it does. I think also, I think you might have answered this, but maybe I didn't quite catch it. How is it handled right now, in the sense of, like, so when a contract responds to you, or when you kind of do dealings with a contract, there's no way to know whether or not that's actually coming from the contract. So isn't that like a security vulnerability that exists currently?
Sorry, can you repeat what do you mean by it? You have no way of knowing if it comes from the contract?
Right. So as I understood,
yeah, maybe to give an example, you have a Gnosis Safe wallet or Argent wallet, and I am a dApp, and I try to say, like, okay, in order to log in my dApp, you have to send a message to prove that you are in control of that wallet, right? Many applications do that. They say, can you sign with MetaMask or this random message, in order for you to prove that you are in control of that wallet. Now, that dApp would basically request a signature from Gnosis Safe or Argent or whatever. And then in order to validate if it's a valid signature for that specific wallet, it would do this here. It would call the isValidSignature method on your wallet address, passing the wallet address, and it would ask your wallet, by doing a contract call via the blockchain, say, if I pass this hash and with this with that signature, is this a valid signature? And then your wallet, the contract itself of your wallet, will return, is this a valid signature or not? So that's how it works, basically.
Okay, thank you.
Yep, no problem.
Well, it was really interesting that you started your presentation today by talking about the ENS proposal, the RFP that was live by the Ethereum Foundation recently. And that was a very good example. It created the relevance right away why we needed this proposal. So thank you so very much for that. Thank you.
Pleasure.
Taking out time and talking about this proposal. I hope this will be added as a standard, as it is already being used in many projects. On this note, for all our YouTube viewers, thanks for watching. If you like it, please share it with people of similar interest. And we have added guest Twitter handle, the presentation, and some of the resources related to this proposal in the description section. Give it a look. Do let us know which proposal you would like to hear next in this series. As usual, I'll be looking forward to your feedback. Reach me or any of the cat herders on Twitter or ECH Discord with any suggestions. We will keep getting you interesting talks. Stay tuned, keep watching, keep sharing your love with Ethereum cat herders.